What do Albert Einstein, the Global Positioning System, or GPS, and a pair of stars 200,000 trillion miles from Earth have in common? The answer is an effect from Einstein's general theory of relativity, called the gravitational redshift. This is when light is shifted to redder colors by the effects of gravity. Using NASA's Chandra X-ray Observatory, astronomers have discovered the phenomenon in a stellar couple in our galaxy about 29,000 light-years, or about 200,000 trillion miles away from Earth. Gravitational redshifts have tangible impacts on modern life, as scientists and engineers must take them into account, for example, to enable accurate positions for GPS. While scientists have found incontrovertible evidence of gravitational redshifts in our solar system, it has been challenging to observe them in more distant objects across space. The new Chandra result provides convincing evidence for gravitational redshift effects at play in a new cosmic setting. The intriguing system, known as 4U 1916-053, contains two stars in a remarkably close orbit. One is the core of a star that has had its outer layers stripped away, leaving a star that is much denser than the Sun. The other is a neutron star, an even denser object, created when a massive star collapses in a supernova explosion. These two compact stars are only about 215,000 miles apart, roughly the distance between the Earth and the Moon. While the Moon orbits our planet once a month, the dense companion star in 4U 1916-053 whips around the neutron star and completes a full orbit in only 50 minutes. In the new work on 4U 1916-053, the team analyzed X-ray spectra, that is, the amounts of X-rays at different wavelengths from Chandra. They found the characteristic signature of the absorption of X-ray light by iron and silicon in the spectra. In 3 separate observations with Chandra, the data show a sharp drop in the detected amount of X-rays close to the wavelengths where the iron or silicon atoms are expected to absorb the X-rays. However, the wavelengths of these characteristic signatures of iron and silicon were shifted to longer or redder wavelengths compared to the laboratory values found here on Earth. The researchers found that the shift of the absorption features was the same in each of the 3 Chandra observations, and that it was too large to be explained by motion away from us. Instead, they concluded it was caused by gravitational redshift. In addition to confirming Einstein's ideas from over a century ago, this work also provides a way for researchers to learn about the system itself. For example, the astronomers were able to precisely determine the distance between a gaseous cloud around the neutron star and the star's surface. Scientists have been awarded further Chandra observations in the upcoming year to study this system in more detail.